Welcome to an Achieving Science video. This video is going to look at exothermic and endothermic reactions. First of all, let us begin by looking at some facts about chemical reactions. A chemical reaction is something that involves a permanent change and not just a temporary one. Within a chemical reaction, mass isn't lost. Instead, we say that mass is conserved. A chemical reaction can be shown via a word equation to show what exactly is going on. Chemical reactions always involve a change in energy, a change in temperature. There can be visible changes that occur, e.g., a gas could be given off, a solid could be formed, or there could be colour changes. So then, exothermic and endothermic reactions. Let's have a closer look. An exothermic reaction is one which gives out energy to the surroundings. Usually this is as heat and is shown by an increase in the surroundings' temperature. On the other hand, an endothermic reaction is one which takes in energy from the surroundings, usually as heat, and this is shown by a decrease in the surrounding temperature. Now, in order to understand this in a bit more detail, we need to look exactly what is happening during a chemical reaction. So what is happening? Well, during a chemical reaction, bonds need to be broken and new bonds need to be formed. In order to break bonds, energy is required, and energy is released upon new bonds being formed. Now, this is crucial to understand the difference between exo and endothermic reactions, because if more energy is needed to break bonds than is released from forming bonds, the reaction is said to be endothermic. It's taken in more heat than it has released, and therefore it's taken in energy from the surroundings. If more energy is released, on the other hand, from forming bonds than is needed for breaking bonds, the reaction is said to be exothermic. It is giving out heat, remembering that exo means exit, leaving, as where endo means taken in. So in an exothermic reaction, the surroundings will get hotter. Now, this can be shown using a reaction profile. So this is a graph which actually shows you what's happening. So on this graph we have energy and we have time. Now, we start off with the reactants and the amount of energy that the reactants have initially. And we can see that the products in this case have a lower amount of energy. Now we can draw a second graph, which is the opposite, where we have the reactants have a lower amount of energy, whereas the products have a higher amount of energy. Now, the first graph is an example of an exothermic reaction, because the energy has been released from the reactants, as where the endothermic is shown on the right hand side. So in the first example, the products have less energy than the reactants, as where in the endothermic reaction, the products have more energy than the reactants. Now, in both of these graphs, you'll see that there is a little rise in the amount of energy. Now, the initial rise represents the energy needed to break the bonds. This is important. This is called the activation energy. This can be shown on the graph via an arrow. What else can be shown is that the difference, the overall energy change, can be also shown. This is shown by the red arrows on the graphs above. These are important two annotations to be made to these graphs.